Welcome to the Otters Share, a sun-warmed flat rock at the river bend where the day's fresh catch is carefully divided. This is Sedge. Every day he faces the practical challenge of dividing the river's catch fairly among the young otter pups. To distribute the food, Sedge uses two completely different physical actions. Sometimes he has to share a small piece among several pups, making it even tinier. Other times he has whole fish, and he measures out how many portions fit inside. Fraction division is simply recognizing whether a situation calls for sharing or measuring, and then proving the result by multiplying it back. Let's look at the first scenario. Sedge has only a small fraction of a catch, just 1/3 of a single fish, but he must distribute it equally among 4 waiting pups. To manage this scarcity, Sedge uses his webbed paws to physically split that single piece into 4 even tinier pieces. Looking at the math on this leaf, we start with 1/3. Divided among 4 pups, each pup receives exactly 1/12 of a fish. Because division and multiplication are inverse actions, we can gather those shared pieces back together to verify the math. The 4 1/12 pieces lock back into the original 1/3. 1/12 times 4 equals 1/3. Sharing a unit fraction among a whole number of pups guarantees that each individual share gets smaller. Now Sedge shifts to a scenario of abundance. He starts with 4 whole fish and moves to the second physical action, measuring. He needs to know exactly how many 1/5 portions fit inside the total catch, so he cuts the fish to find out. This diagram maps out the results. Each whole fish holds 5/5 pieces. Across 4 fish, that totals 20 pieces. 4 divided by 1/5 is 20. We can prove this larger yield through the same verification process. The 20 individual pieces recombine into the 4 original whole fish. 20 times 1/5 is 4. Dividing a whole number by a unit fraction is the act of measuring how many small pieces fit inside. It always results in a larger quantity of pieces. Let's apply this to a real-time feeding line. Sedge has 3 whole fish and needs to determine how many pups he can feed if each requires exactly a 1/4 fish serving. He portions out those specific quarter servings, using his paws to carefully slide the fish across the flat rock to the hungry pups. We can map out the distribution here. With 4 quarter servings per fish across 3 fish, Sedge can feed 12 pups. 3 divided by 1/4 equals 12. Even in a practical feeding scenario, the mathematical check works exactly the same way. Consolidating the 12 servings reconstructs the 3 original fish. 12 times 1/4 is 3. Distributing resources in the wild relies heavily on this type of division, counting how many fractional servings fit into a whole amount. Sedge has successfully managed the day's catch. Beside him, you can see the results of both physical actions, each paired with its proof. Sharing a small piece among many makes the pieces smaller. Counting how many small pieces fit in a whole creates more pieces. Regardless of the action, multiplying your answer back by the divisor is the universal proof. With the very last piece of the catch carefully distributed to the pups, the hard work at the Otters Share is finally done. Share it smaller or count how many fit, then multiply back. I'll see you at the next bend. Before you go, try this. How many 1/3 fish servings fit into 2 whole fish, and what multiplication equation checks your answer?